Welcome to today's lecture. The subject is chemistry. Today we'll be looking at hydrolysis of salt. Hydrolysis of salt. Hydrolysis of salt is a chemical reaction where the ions of the salt react with water to form an acidic or a basic or neutral solution. Don't forget, it says where the ions of the salt. So I want you to commit that to memory. Hydrolysis has to do with ions of the salt reacting with water. So that's the basis of this study. Hydrolysis of salt has to do with the ions of the salt reacting with water. Note, some salts dissolve in water without changing the pH. Such solutions are said to be neutral. Others change the pH, and then when this pH changes, the solution either becomes acidic or basic, depending on the ions present. So the ions that are present or that are able to interact with water determine whether the solution will be acidic, basic, or neutral. So let's see which salts undergo hydrolysis. Hydrolysis happens if the salt is formed from, number one, strong acids and weak base, weak acids and strong base, strong acids and strong base, weak acid and weak base. We will talk about this later. So let's see a list of strong acids. Let's remind ourselves of strong acid. Don't forget, a strong acid is one in which a strong acid is one that dissociates completely or totally in an aqueous solution in water. So I want you to commit this to memory. It dissociates or ionizes completely, not partially. So some of the examples of strong acids are H2SO4, HCl, HNO3. So H2SO4, that's tetrasulfate 6 acid, HCl, hydrochloric acid, HNO3, trioxonitrate 5 acid. Strong bases. A strong base is the one that will dissociate completely in water or aqueous solution. And some of the strong bases are sodium hydroxide, potassium hydroxide, calcium hydroxide. Now, other strong acids are HClO4. This is perchoric acid. Perchoric acid. HBr, hydrobromic acid. HI, hydroiodic acid. These ones are not common. The common ones are the ones we looked at here. So it means that if any acid does not make the list that we have looked at now, the acid is termed a weak acid. There are a good number of weak acids. We cannot list all of them here. So we're saying that if you look at the list of acid that we have taken and that acid is not found in this list, then the acid is a weak acid. Other strong bases are barium hydroxide, lithium hydroxide. So if you look at the list of the bases we gave here, and you consider the base you're working with, if the base you're working with is not found in the lists here, then of course the base is called a weak base. A weak base. Okay, so let's move directly now properly into the topic. Remember we said hydrolysis of salt has to do with ions reacting with water. So I want you to note this. Number one, cations of strong bases, that is Na+, K+, Ca2+, as sodium ion, potassium ion, calcium ion, do not react with water. They do not react with water. Strong bases are fully ionized or dissociated, and the cations are very stable. That's one of the reasons. Remember we said a strong base is one that ionizes or dissociates completely in water. And because they do this fully, that is, because they ionize completely or fully, the ions tend to be very stable. Hydrolysis occurs when an ion can accept or donate a proton. Now don't forget we said that hydrolysis is tied to ions reacting with water. So if the ion can donate or accept, don't forget, look at it. Hydrolysis occurs when an ion can accept or donate a proton or react with water to form OH- or H+. So hydrolysis sets in when the ions of the salt can either accept or donate a proton to form OH- or H+. When this happens, we say hydrolysis has taken place. Na+, K+, Ca2+ are very weak acids, so they cannot react with water. Na+, K+, Ca2+ are weak conjugate acids of strong bases. Since they are weak, they barely donate H+ to water, and as a result, there is practically no hydrolysis. Na+ plus water, the reaction is negligible. No reaction takes place. Ca2+ plus water, negligible reaction, no reaction takes place. K+ plus H2O, negligible, no reaction takes place. No hydrolysis occurs with Na+, K+, Ca2+. Let's take a quick rule. The conjugate acid Na+, K+, Ca2+. So with Na+, K+, Ca2+, these are ions from strong bases. No hydrolysis takes place because these ions cannot react with water. So weak conjugate acids, a weak conjugate acid does not mean the solution is acidic. It just means the cation could theoretically act as an acid, but it is too weak to do so. You will need to follow closely and listen properly for you to understand the technical terms used here. Number 2 now, anions of strong acids, Cl minus, NO3 minus, SO42 minus, do not react with water. Remember, hydrolysis of an ion happens when it can accept a proton from water to form an acid. Strong acid conjugates, that is strong acid conjugates, that is Cl minus, that's chloride ion, tetraoxosulfate 6 ion, triazonitrate 5 ions, are very weak bases and they cannot accept H+. Therefore, they do not react with water. And no OH is formed. Again, Cl minus, chloride ion plus water, no reaction. Triazonitrate 5 ion plus water, no reaction. The same thing goes with tetraoxosulfate 6 ion, no reaction. So let's look at the quick rule again. Conjugate base. The conjugate base, Cl minus, that's chloride ion, no hydrolysis. SO42 minus, tetraoxosulfate 6 ion, no hydrolysis. NO3 minus, no hydrolysis. Now, the reason for this is because strong acids dissociate completely in water, and when they do so, they form stable anions, which are referred to as strong conjugate acids. And these strong conjugate acids form very weak bases, and they cannot accept H+. Therefore, they do not react with water. Let's look at the quick rule. The quick rule, conjugate base, Cl minus, SO42 minus, NO3 minus. Of course, they do not react with water, so no hydrolysis. The quick rule now is for strong acids and weak acids. Quick rule for strong acids and weak acids. Anions of strong acids do not hydrolyze. Anions of weak acids like ethanoate ion, triazocarbonate 4 ion, tetraoxophosphate 5 ion hydrolyze, and when they do so, solution becomes acidic. Quick rule for strong bases and weak bases. So let's back up a bit. Anions of weak acids like ethanoate ion, triazocarbonate 4 ion, tetraoxophosphate 5 ion hydrolyze, and when they do so, solution becomes basic. I beg your pardon, basic, not acidic. Quick rule for strong bases and weak bases. Cations of strong base or bases do not hydrolyze. We've talked about that before. Cations of weak bases like ammonium ion hydrolyze, and then the solution becomes acidic. Let's see examples. Sodium triazocarbonate 4, that's Na2CO3. The Na2 is from a strong base, sodium hydroxide. The CO3 is from a weak acid, H2CO3, that's triazocarbonate 4 acid. Now, in a layman's language, the stronger rules an environment. So because this salt is made from a strong base, and because the base is stronger, the pH is greater than 7. So when you have a salt from a strong base and a weak acid, the strong base rules that environment, the pH becomes greater than 7. Looking at it from another angle, if this dissociates, it's going to give you Na plus CO3 2 minus. So Na plus now does not hydrolyze, so it's neutral. CO3 hydrolyzes to produce OH minus, that's basic. Let's look at it. CO3 2 minus plus water will give you this and OH. So it accepts proton to produce OH minus, which is basics. So the pH is greater than 7. Let's look at number 2. Sodium chloride, NaCl. Na is from a strong base, that's NaOH. Cl is from a strong acid, HCl. Okay, they have equal strength. They have equal strength. Strong base, strong acid. So when you have a strong base and a strong acid, the pH is neutral, which is equal to 7. Technically now, Na plus does not hydrolyze and forms a neutral solution. Cl minus does not hydrolyze, it forms a neutral solution. And so then the pH of this becomes 7. Let's look at number 3, NH4Cl ammonium chloride. NH4 is from a weak base, Cl is from a strong acid, that is HCl. HCl, this is a weak base, this is strong acid. The stronger rules the environment, so the pH is less than 7. Now technically, if we look at Cl minus does not hydrolyze, so forms a neutral solution. NH4 plus hydrolyzes to form H plus. Okay, so NH4 hydrolyzes, that is NH4 plus water, will give you ammonium hydroxide plus H plus. So it hydrolyzes to produce H plus. Cl minus does not hydrolyze, so it's neutral. So the resulting solution becomes acidic because of the presence of the H plus. So then pH is less than 7. Looking at it ordinarily, without going through this method, we can just say that it's from a weak base, NH4. Cl is from a strong acid. The stronger rules the environment, and so the pH is less than 7 since the acid is actually ruling the environment. Summary now. If you have a strong acid and a strong base, the pH will be equal to 7. The pH of the resulting solution will be equal to 7. If you have a strong acid and a weak base, the pH will be less than 7. If you have a weak acid and a strong base, the pH will be greater than 7. If you have a weak acid and a weak base, the pH depends on Ka and Kb. Ka means acid dissociation constant. Kb means base dissociation constant. Ka, it measures the strength of an acid in water. It tells us how much an acid ionizes, that is, produces H plus in solution. Kb, which is the base dissociation constant, measures the strength of a base in water. It tells how much a base ionizes, that is, produces OH minus in solution. So let's look at the summary table. These are the constant now, that is the acid dissociation constant, the base dissociation constant. If the value of the acid dissociation constant is large, then we say that the pH will be less than 7. If it is also large for the base dissociation constant, we say that the pH will be greater than 7. That is, for weak salts, we compare the Ka of the cation and the Kb of the anion. If the Ka is greater than the Kb, it means that the solution is acidic, that the pH will be less than 7. If the Ka is less than Kb, that is Kb is greater than Ka, the solution will be basic, that means the pH will be greater than 7. If the Ka is equal to Kb, it means that the solution is neutral and pH will be equal to 7. I would like you to attempt the following questions. State whether the pH of each of the following salt will be less than 7, greater than 7, or equal to 7. Number 1, potassium chloride, KCl. 2, or B, potassium trioxocarbonate 4, K2CO3. C, ammonium tetraoxosulfate 6, NH42SO4. D, sodium ethanoate, CH3COONA. E, potassium ethanoate, CH3COOK. Aluminium chloride, AlCl3. Calcium chloride, CaCl2. Potassium, Cl, strong base. K is from a strong base, Cl is from a strong acid, so you know what that means. K is from a strong base, CO3 is from a weak acid, you know what that means. NH4 is from a weak base, SO4 is from a strong acid, you know what that means. CH3COO is from a weak acid, Na is from a strong base, you know what that means. CH3COO is from a weak base, K is from a strong CH3COO is from a weak base, K is weak acid, I beg your pardon. CH3COO is from a weak acid, K is from a strong base, you know what that means. And then you follow through until you get to the end. I'll see you in the next lecture.